I have an off-grid solar energy system to power a couple of computers and the lights around my house. In the past, every time I wanted to check the voltage level of the batteries, I had to press a button on the charge controller, then I had to wait for the controller to go through several changes on the digital display, which was a bit of a cumbersome process. One solution was to use a separate digital voltmeter, but its screen was small, in addition to the drain of the meter batteries, and, the meter being a shop tool, it was not very practical to have it wired in all the time. A good friend of mine gave me as a gift an old analog voltmeter, which had some burnt components, but the D'Arsonval movement was in good condition. I modified this analog meter by removing the entire internal circuit board and adding some resistors, so I was able to read the voltage of my system's battery off one of its scales. That was fine, but another small difficulty arose. The readings I was interested in were between 12.4 and 14.6 volts, just a few millimeters apart on the dial. In any case, you had to go up to the device and count the scale lines, which wasn't very practical either. An inspiration hit me. To expand the scale, making the needle to point approximately 1/3 up of the scale for 12.4 volts, and 2/3 up of the scale for 14.6 volts. When the needle was at half scale, it would indicate the trickle charge voltage of 13.5 volts. It would be easier to tell if the needle was totally vertical, to indicate normal trickle charge condition. If it tilted to the left, it indicated low voltage. If it leaned to the right, it indicated a charging process voltage. With a reading like this, you could tell, at a glance, what the current voltage was, without having to get closer to the dial. The way I solved it was very easy. First, I added the necessary multiplier resistors to the instrument, since it could approximately indicate full scale, whenever there were 13 volts in the system battery. The resistors values depend on the voltmeter used. Mine was originally 30,000 ohms per volt DC. The multiplier resistors I used were connected in series for resistors of 560,000 ohms each, so the total resistance added up to 2,240,000 ohms. In series with them, I added a 1 megohm potentiometer to finally adjust the center position of the needle. In series with the input of the instrument and multipliers, I installed 4 low-intensity LED diodes, the kind used as indicator lights in some projects. If the correct scale expansion is not achieved, some LEDs can be added or removed. By doing that, I managed to get the instrument to reach the center of the scale, whenever there were 13.5 volts in the system battery. That way, if the needle is vertical, the system batteries will be floating. Whenever the system voltage is low, the needle will tilt to the left. Whenever the system voltage is high, the needle will tilt to the right. The distance between the two extreme positions of the needle will be approximately 20 millimeters, a distance noticeable at a glance, without getting closer to the instrument. You can even stick a piece of yellow electrical tape in the area you want to label as floating to make readings even easier. If my experiment is of any use to you, I would like to read your comments. I hope you found this video interesting. Please subscribe to my channel. Shava Tareen is inviting you.